Our users connect to each other and to different services by using communication networks. Large and complex infrastructure continuously evolving that are made up of multiple nodes, components, and links. A network has a strong dependence on hardware, that's to say, on the physical equipment. This characteristic makes it a very rigid and expensive infrastructure to operate. Making changes to it, to evolve or to make the launch of new products and services possible, often involves long periods of time. The inclusion of new functionalities is delayed by the need for economies of scale in order to manufacture the specific network hardware, as well as by the long standardization processes between the vendors and operators. What's more, the very complexity of the network makes it hard to introduce changes from the perspectives of management, configuration, and control. In this situation, we need to transform the network to make it a much more flexible, nimble, and moldable infrastructure. The network must be able to adapt in a better way to the quick pace imposed by the evolution of the digital world. To that end, we have network virtualization as a significant lever for transformation. Network virtualization is composed of two technologies, NFV and SDN. Virtualizing the network consists of separating software from hardware and network equipment so that network functionalities become independent of the physical equipment supporting them. As all functionalities are found in software and not in the physical machines, the same server can be used for several purposes depending on the software installed on it. As functionalities reside exclusively in software, it is possible to package each network function in one or more virtual machines and to decide where to execute them. This is what's known as Network Function Virtualization, or NFV. This new concept is now feasible because a set of advances in general-purpose servers has managed to increase by an order of magnitude the performance that software can achieve in the handling of data. These advances have turned commercial off-the-shelf servers into the ideal candidate for network virtualization, owing to the significant economies of scale they represent. This is not a trivial process. Hardware resources must be allocated with great care in order to achieve high and predictable performance so that virtualized network functions can work at the same speed as traditional network functions. At the same time, those network functions must be interconnected with each other in a coherent way in order to provide network services. These interconnections can be managed from a centralized point. The centralization of the control plane is what is known as software-defined networks, or SDN. And what advantages does this new concept bring? It will be possible to install various network nodes on the same infrastructure, so it will be possible to share capacity among them. Thus, when there is a change in demand, instead of purchasing new network nodes, we can change the software to balance the capacity according to needs in a dynamic way. At the same time, from the point of view of management and investment, virtualized network functions will be more efficient than traditional ones. As this technology is gradually installed, the network will become a moldable infrastructure in which it will be possible to deploy functions on demand, quickly and efficiently. The installation and configuration will be carried out in a more automatic way, making the process more economical while also making the network more resilient and simplifying the management of the functions already installed. The traditional and virtualized network worlds will have to live together during this process, so the transformation can be carried out gradually to support the flexibility and scalability that the telecommunications infrastructure of the future requires.